So you need to be able to define current, charge and energy, obviously, we've done that, as well as voltage, but you need to know the symbols for each charge, current, voltage and energy. So charge, the symbol is Q, so you're just going to write the symbols in an equation that would be Q equals instead of having to say charge equals. The unit of which is coulombs, so capital C. So in an exam question, for example, if you saw 300 MC, then it would be millicoulombs, for example. Current is the symbol I, we measure that in amperes, capital A. Voltage V in volts, which is straightforward. Energy is E, which is joules, and we've done that before. You need to define what 1 coulomb of charge is. So you've just introduced the unit of charge, which is the coulomb, but we have to be able to say what is 1 coulomb, what does 1 coulomb represent? So 1 coulomb is the charge passing a point in a circuit with 1 ampere in just 1 second. So if you write this as a definition for what the coulomb is, which is a measure of charge, passing a point in a circuit with 1 ampere in 1 second, then you can write this equation, which is Q charge equals current times time. So Q equals IT, and that's from the definition of the coulomb. Okay? Potential difference then, we've got voltage. A new definition for voltage, although we already said potential difference is the amount of potential energy that is provided by a supply in a circuit or taken by a component. A better definition is that the voltage is the amount of energy transferred to each coulomb of charge. So you define the coulomb and then you say, well, potential difference is actually the amount of energy that's being transferred to each coulomb of charge. What does that mean? If I had a supply of 1 volt, then that supply would be transferring 1 joule of energy to every coulomb of charge in that circuit. So for example, if I had to supply a battery that was 10 volts, then 10 joules of energy would be transferred to every single coulomb of charge. Now, the coulomb, the charge itself, obviously only electrons and protons are charged. Both of the particles have the same charge, just opposite sign, but they're not 1 coulomb each. So each electron isn't 1 coulomb, it's actually 1.6 times 10 to the minus 19 coulombs. So just 1 electron has a very, very small charge. But if you had a coulomb of charge, which is around 6 billion electrons in total, then 1 volt would give 1 joule of energy to that 1 coulomb. Those 6 billion electrons would have to share the 1 joule. Okay, and that's how the energy works. Again, if you have this as a definition, then you can write an equation which is energy is equal to charge times voltage, because the volt is energy per charge, which means Q would go underneath energy. So E equals QV is the second equation in this 10C, Q equals IT is the first, and just using those equations is primarily the main thing you need to know for 10C.